Imagine a world where traveling to space is as routine as catching a flight to another city. Sounds like science fiction, doesn't it? But what if I told you that this could become a reality thanks to an idea that's been around for over a century? The space elevator. Hi there, welcome back to Space. Today we're diving deep into the $1 trillion vision that could revolutionize space travel as we know it. So grab a comfy seat and let's embark on this thrilling journey together. You might be wondering, what exactly is a space elevator? In simple terms, it's a structure that connects the Earth's surface directly to space, allowing cargo and perhaps even people to travel up and down without the need for rockets. Think of it like an elevator shaft stretching from the ground all the way into orbit. Wild, right? But wait, is that even possible? Let's break it down. The concept of a space elevator was first proposed in 1895 by Russian scientist Konstantin Tsiolkovsky after he was inspired by the Eiffel Tower in Paris. He envisioned a tower reaching all the way into space. Fast forward to today, and advances in materials science and engineering are bringing this wild idea closer to reality. Now you might be thinking, building a structure from Earth to space sounds insanely difficult. And you'd be right. The challenges are immense, but so are the potential rewards. Consider this. Launching payloads into space using rockets is incredibly expensive and inefficient. Currently, it costs around $2,700 per kilogram to send something into orbit. With a space elevator, those costs could drop dramatically, potentially as low as $200 per kilogram. Imagine the doors this could open. But let's talk about the real game changer here. A space elevator could enable continuous transportation of goods and materials to and from space. This means more satellites, more space stations, and perhaps even the ability to build habitats beyond Earth. It's not just about saving money, it's about opening up new possibilities for exploration and even tourism. Now I know what you're thinking. What about the technical challenges? Building a structure tens of thousands of kilometers long is no small feat. One of the biggest hurdles is finding a material strong enough to withstand the immense tension. Traditional materials like steel just won't cut it. This is where carbon nanotubes and graphene come into play. These materials are lightweight yet incredibly strong, potentially strong enough to support the weight of a space elevator. But producing them in the necessary lengths is still a work in progress. Let's delve a bit deeper into the fascinating world of materials science. Imagine weaving a thread thinner than a human hair but strong enough to hold massive weights. It's like trying to build a bridge out of spider silk, but on a cosmic scale. Speaking of spider silk, did you know that weight for weight, spider silk is stronger than steel? Nature often inspires us in the most unexpected ways. Back to the space elevator. Another intriguing aspect is the climber, the vehicle that would ascend and descend the tether. Instead of traditional fuel, these climbers could be powered by lasers beaming energy from the ground. Think about it like this. It's similar to how wireless charging works for your phone, but on an immensely grander scale. Energy beamed from Earth propels the climber upward, making the journey sustainable and continuous. But here's the exciting part. Researchers are actively working on these problems. Advances in nanotechnology and energy transmission could make the creation of a space elevator possible within our lifetimes. Just imagine the doors this would open. By the way, if you're enjoying this exploration into the future of space travel, make sure to hit that like button and subscribe to Space. We dive into topics like this all the time, and you won't want to miss what's coming next. So, back to our journey. Another challenge is the Earth's rotation and gravitational forces. The space elevator would need to be anchored at the equator and extend beyond geostationary orbit, creating a balance point where centrifugal force offsets gravity. It's like spinning a ball on a string. The tension keeps it taut. Weather events like storms and high winds pose additional risks. Engineers propose using mobile ocean platforms as anchor points to avoid these issues and to place the elevator directly along the equator where weather patterns are more predictable. Security is another concern. The elevator would need to withstand potential impacts from space debris and meteoroids. Protective measures like shields or tethers that can self-heal and careful monitoring of space traffic would be crucial. But let's shift gears a bit. Think about how the railways transformed the 19th century, connecting continents and fostering trade and communication. A space elevator could have a similar transformative effect, but on a cosmic scale. Imagine the possibilities. We could transport solar panels into orbit to capture solar energy and beam it back to Earth, providing a clean and abundant energy source. We could ship materials to the Moon or Mars more efficiently, accelerating exploration efforts. Even space-based manufacturing could become a reality, creating products that are difficult or impossible to make under Earth's gravity. Moreover, space-based solar power stations could play a significant role in addressing energy needs and combating climate change. By placing solar panels in space where they can collect sunlight continuously without atmospheric interference, we could beam that energy back to Earth, providing a constant, renewable energy source. And it's not just about science and industry. A space elevator could inspire a new generation of thinkers and dreamers, much like the moon landing did in the 20th century. It could be the catalyst for a new era of innovation and exploration. Now you might ask, who's working on this colossal project? Various space agencies and private companies have shown interest. In Japan, the Obayashi Corporation has expressed plans to build a space elevator by 2050. They're serious about it, investing in research and development to tackle the obstacles we discussed earlier. In addition, international organizations like the International Space Elevator Consortium are hosting conferences, bringing together scientists, engineers, and enthusiasts to collaborate on making this vision a reality. Of course, there's the question of funding. A project of this magnitude could cost around $1 trillion. That's a hefty price tag, but consider the long-term benefits and returns on investment. Reduced space travel costs could open up economic opportunities we can't even fully grasp yet. It's a big gamble, but remember, there was a time when the idea of humans flying seemed impossible. Yet here we are, hopping on planes without a second thought. Speaking of big ideas, let's ponder this. What would it feel like to ride an elevator into space? The journey could take about a week to reach geostationary orbit. Passengers might experience the gradual fading of Earth's atmosphere, witnessing the curvature of our planet in a way only astronauts have before. Imagine looking out the window as the blue sky fades to black, stars becoming visible even during the day. The sensation would be surreal, a journey from our world into the vastness of space without the violent force of rocket propulsion. Now, let's address some of the concerns. What about safety? How do we protect passengers and cargo? Engineers are exploring various safety measures, like emergency descent systems and multiple redundancies. The space elevator would likely have numerous safety protocols, similar to how modern elevators have brakes and backup systems. And then there's the environmental impact. Interestingly, a space elevator could reduce the carbon footprint associated with rocket launches. By providing a more energy-efficient means of reaching orbit, we could lessen the environmental impact of our growing presence in space. But with all these possibilities, we must also consider the ethical and regulatory implications. Who would control the space elevator? How do we ensure equitable access and prevent monopolization? These are complex questions that would need careful thought and international policies. As we're exploring these big ideas, it's important to stay grounded. While the challenges are significant, each step we take brings us closer to making the space elevator a reality. It's about pushing boundaries, embracing innovation, and daring to dream big. So, what's next? The coming years will be crucial. With advancements in material production, robotics, and energy transmission, we're steadily chipping away at the barriers. Who knows? Maybe the first space elevator will start construction sooner than we think. If you're as fascinated by this as we are, make sure to subscribe to Space. Together, we'll keep exploring the frontiers of human knowledge and imagination. Before we sign off, here's something to ponder. Every monumental achievement in human history started with a bold idea, a vision. The space elevator is one such vision. It's audacious, challenging, and perhaps a little bit crazy. But isn't that what makes it worth pursuing? We'd love to hear your thoughts on this ambitious project. What excites you most about the possibility of a space elevator? Do you think we'll see it in our lifetime? Share your insights in the comments below. Thank you for joining us on this incredible journey through the possibilities of space travel. Remember, the sky is not the limit, it's just the beginning. Until next time, keep dreaming big and looking up.